What's up, people? Welcome back. Welcome back. I hope all of you guys are doing good. I know that you're looking forward for your weekend, and more importantly, your exams are right around the corner. You have about 17 days left, including today. Excluding today, that's 16 days are left for your boards, and I hope that your preparations are going good. I hope you have started with your revisions already because this is that stage where you should be doing more PYQs, that is previous year question papers, sample papers, and mock tests and whatnot. So I'm hoping that all of you guys are in that state right now. Welcome to the session because today, people, we are going to be doing one mock test of our own. Today, we're going to be doing the term one mock test for physics, session number one. We're going to be having a lot of these kind of series in the future as well. So make sure you subscribe to the channel, make sure you hit the like button, and also share the video with your friends if you feel like this session is going to be helpful for them as well. Yeah, let's be kind, right? Anyways, now before we get started, I hope that the weather in your place is pretty good because it's been all wet and all cold, all very, very chilly in Bangalore. But at least I hope that it's better in your place, at least. Hoping that you guys are staying safe. It's important that you don't fall sick, guys. You have another 18 days, sorry, 17 days left, including today, that is. So I'm hoping that you guys are staying safe, staying warm. It's important that you don't fall sick at this point of time. You can't afford to do that. So stay warm, drink only hot water and nothing else, and yeah, stay safe, right? So let's get into the topic, guys, without wasting much more time. So like I told you guys, this is going to be CBSE Class 10 mock series where we'll be analyzing a mock test paper. We'll try to solve these questions as fast as we can. Now here's what I want you guys to do. I want you guys to take a pen, paper, and I want you guys to solve each and every one of these questions. I don't want any of you guys to sit there and just watch the video because it's physics. So that means that you have to practice by yourself as well. So it's very important that you guys actually try out the questions by yourself and see for yourself if you're able to solve these questions or not. Now, here's what I want you guys to do. After all the questions are solved, I want you guys to let me know chat in the comment section and in the chat box how many questions were you able to get it right throughout this particular session, and whoever gets the most number of questions right, their name would be put up in the next mock series that comes up. So if you want your name, you want to become famous in whatever little way possible, make sure you put it out in the comment section as well and see for yourself if you're able to solve these questions or not, right? So my name is Anoop. Welcome to Vedantu 9th and 10th English channel. So let's get into it, guys. And yes, amazing news for all the education lovers out there. EdFest is back, people. EdFest is back, and this time we are back with a bang. 7 days for the longest time ever, for the whole week from 14th of November, from Children's Day, the one whole week that you have, we would be having EdFest where you will be getting, guess what, 50% off, up to 2000 rupees on all of our courses. Doesn't matter which course you take, for all the courses, 50% off up to 2000 rupees in your hands. This is your chance, guys. This is your chance to get into those courses that you always wished for, but because of money problem or because of financial issues you couldn't do it. Because now, people, even I'll tell you how less this price is. I'll explain this in a minute, but before that, guys, let's get into the questions, right? So people, here's what I've done. I have divided the questions into three different levels. You have level 1 questions, level 2, and then you have level 3 as well. So level 1 questions, as you can probably guess, it's going to be quite simple, quite straightforward, quite easy. But level 2 is going to be a little bit more harder, and level 3 is going to be a case study based question. Now again, I want all of you guys to sit throughout the entire session, solve each and every question, and see for yourself, right? So let me stop talking and let's get into the question. Level 1, here it is. A fish underwater is viewing obliquely a fisherman standing on the bank of a lake. The man looks dash to the fish. Would he look shorter? Would he look taller? Would he look of the same size? Or either it can be shorter or taller. Think very carefully and then answer. I'll repeat the question one more time. A fish underwater is viewing obliquely a fisherman standing on the bank of a lake. The man looks dash to the fish. Would he look shorter, taller, same size, or either A or B? Go ahead, guys. Now, I want every one of you guys to try out this question and see for yourself if you are able to solve this question or not. Now, I'll be giving the answer. I'll be giving you a very short amount of time. But yeah, that's virtually speaking. Since it's a premiered session, please pause the video and see if you need more time. Take as much time as you want, but do not Google it. Do not ask your friend. Do not ask your classmate or your sister or your brother. I want you guys to solve it by yourself, right? So the answer in 5, 4, 3, 2, 1, he is gonna look taller. Let me tell you why. Because when the fish is viewing underwater, the fish, right? Let me try to draw a fish here. Yes. Now, if the person is standing on the bank, now light is traveling from a denser to rarer medium. That means that it is going to bend away from the normal. It's going to bend away from the normal. So if I take two rays of light, what would happen is that because of refraction, the person, because it's bending away from the normal, he would actually look taller than he is. Now, if on the other hand, if the question was if the person is watching the fish from the bank or from the bank of the river, that would have been shorter. Why? Because light is traveling from a rarer to denser medium, so it's going to bend towards normal. So it look a little more like when you look at the depth of a bucket or something, it looks higher than its actual position. So that would have been the case. Here they're talking about the fish looking at the fisherman, so that would have been taller because again light is bending away from the normal. Too much explanation, right? But yes, the answer for this question is going to be option number B. Moving on to the second question, guys. Here is the second one. What will happen to a ray of light when it falls normally on a surface? If a ray of light is coming and falling normally to the surface, what would happen? Would it bend towards the normal? Would it bend away from the normal? No bending occurs, or either A or B. Again, I'm going to give you 10 seconds to think about it. Again, if you need more time, always pause the video. Think about the answer, put it on your notebook, put it out mentally if you have to, write it down somewhere if you can, or more importantly, put it out in the comment section or in the chat box, right? I'll give you the answer in 5, 4, 3, 2, 1. Option number C is, if a ray of light is inciding exactly at normal, then the angle of incidence is 0. That means that this ray of light would pass through undeviated without any deviation whatsoever. So the angle of refraction also would be 0 degrees. That's it, guys. Super duper easy question. So the answer is going to be bending. No bending occurs whatsoever. Third question, right? I hope you guys have done so well so far. Here's your third question. The magnification M for a mirror is +1. What does this signify? If the magnification of a mirror is given as +1, what do you mean? What does it mean exactly? What is the type of image that is formed by that image? Options are: image of the object is of the same size as that of the object, image is virtual and erect, image is real and inverted, or is it both A as well as B? Now think very carefully before you answer this. Do not rush into anything. Aram se answer it. Don't worry about all of that. Just chill. Aram se answer it. Alright? Magnification M for a mirror is +1. What does that signify? I'll give you the answer in 5 seconds. 4, 3, 2, 1. Let me tell you this. A lot of you guys would have gone with option number A. That's obvious. At least 50% of you guys would have gone with option number A. But unfortunately, guys, the answer is option number D. Let me tell you why. Because people guess that 1 signifies that the image is going to be of the same size as the object. But that sign plus denotes that the image is going to be erect and virtual in nature, not inverted. It's going to be virtual in nature. Plus indicates that the image formed is above the principal axis, which means that it has to be virtual as well. So it's erect and virtual, and it's of the same size. So the answer would be option number D. Again, please look at the sign, guys. If it was -1, that means that the image is real and inverted, because minus means the image is formed below the principal axis. That means that the image is going to be inverted, it's real, and it's going to be of the same size if it was -1. But here it says +1, so the answer is going to be option number D. Super easy, right? I hope you got this right. If you have made this mistake, make a note of it, because this type of questions you can expect in your boards. So do not ever get this wrong, right? Moving on to the fourth question, guys. Here is the fourth question that I have in store for you guys. An object at a distance of +15 centimeter is slowly moving towards the pole of a convex mirror. the image will get shortened and real, enlarged and real, enlarged in virtual, or diminished in virtual. Think, read the question very, 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 very carefully and then answer. Do not rush into this question at all. Aram se, but with utmost focus. Alright, an object at a distance of plus 15 centimeters slowly moving towards the pole of the convex mirror. The image will get shortened in real, enlarged in virtual, or diminished in virtual. Your answer in 5, 4, 3, 2, 1. The answer is gonna be option number D, people, because it says it's a convex mirror. And convex mirror is always going to form virtual, erect and diminished image. So it doesn't matter all the way from infinity to the pole, wherever you keep it, the image is always going to be virtual, diminished and erect. Always. It's as a convex mirror, that's why. If it was a concave mirror, then it would have been a different case. But it's a convex mirror here. So the answer would be option number D. So with that said, people, level 1 questions are done. Now we have done 4 questions so far. Let me know in the comment section, out of 4 questions, how many questions did you get the right answer for? Is it 4, 3, 2, 1? Be honest. Let me know in the comment section. Let me know in the chat box also how many of you guys got all of the questions right in the level 1 part that we have done. Now moving on to level 2. Again guys, level 2 would have a lot more numericals because so far we didn't deal with any numericals at all. So we'll have a lot of assertion reasoning type questions. We'll have a lot of numericals as well. Now remember, this is just for mirrors. We're talking about spherical mirrors. The next session for mock test paper would be we'll be coming up with lenses, so on and so forth. So it'll go on like that, right? So do not get scared, sir. What about lenses and stuff? We'll be doing that. This is just for mirrors. So we are doing one topic at a time and we're trying to figure out what are the type of questions that can be asked from those, right? So moving on to level 2. Here we go. The absolute refractive index of some of the material is tabulated below. Arrange these materials in ascending order of their optical densities. Now options are: rock salt has a refractive index of 1.54, kerosene has a refractive index of 1.44, water has a refractive index of 1.33, and diamond has a refractive index of 2.42. Now the question is, guys, you have to arrange them in the ascending order. That is lowest to the highest. Now the options are rock salt, kerosene, water, diamond, water, kerosene, rock salt, diamond, rock salt, water, diamond, kerosene, or kerosene, rock salt, water, and diamond. Sorry, diamond and water. Think and then answer, guys. Again, I'll give you guys 10 seconds. I am not cruel. I am the most kindest person. I'm giving you 10 seconds. Just simran ja jile apni zindagi. But if you need more time than 10 seconds, pause the video and put down the answer. You have an option called as pause, right? Use it wisely. All right, I think 5 seconds is more than enough now. Again, if you need more time, pause the video, right? In 3, 2, 1. Here's the thing, guys. The lowest refractive index would be for water because it has a refractive index of 1.33. The second lowest is for kerosene, so that would be second. Right after that, we have rock salt, and then we have diamond. So it's going to be water, kerosene, rock salt, and diamond. So the right answer would be option number B. That's all. Super easy question, isn't it? So please remember this, guys. The higher the refractive index, more the bending of light would happen in that particular medium, more denser the medium is going to be. So here, diamond is the most densest among all the 4. Simple as that. All right. Moving on to the next question, people. Here is another one. Coming back to refractive index once again. Light enters from air into diamond, which has a refractive index of 2.42. Calculate the speed of light in diamond, whereas the speed of light in air is given as 3 into 10 to the power of 8 meter per second. Options are 0.5 into 10 to the power of 8 meter per second, 1.24 into 10 to the power of 8 meter per second, 2.25 into 10 to the power of 8 meter per second, or is it 1.1 into 10 to the power of 8 meter per second? It's such an easy numerical. It looks very complicated, but if you know the concept of refractive index, this is as easy as it gets. Now, if you're confused about this concept, I have made a separate video on the Prodigy series for this. So make sure you check that out, guys. I've done it very, very extensively. You can go through that video. Trust me, you'll understand the concept of refractive index completely completely if you were to go through that video. Just search, go to the channel page, search, scroll up and down, you'll be able to get refractive index wala video. Check it out for yourself, you'll understand it, because I know that a lot of you guys have this confusion still when it comes to refractive index. But anyways, how do you solve this question? Super duper easy. So guys, refractive index of material is equal to speed of light in air, speed of light in air, speed of light in air divided by the speed of light in that medium, whichever medium it is. In this case, it's diamond. So refractive index is given as 2.42, which is equal to speed of light in air is 3 into 10 to the power of 8 divided by the speed of light in the medium. I'm going to take it as x for now. So take it to the other side. So what is x is equal to? 3 into 10 to the power of 8 divided by 2.42, which if you simplify this, you'll get the answer as 1.24 into 10 to the power of 8 meter per second. So the answer is going to be option number B. That's all. Kale Katam Dukan Band. That's it. You just need to remember this formula. See guys, here they're talking, this is called as absolute refractive index. All right. Now here they're talking about the speed of light in air. Now generally when we talk about absolute refractive index, we talk about speed of light in vacuum. But the speed of light in air and vacuum is not much different. Speed of light in vacuum is 3 into 10 to the power of 8 meter per second. And speed of light in air is 2.99 into 10 to the power of 8 meter per second. So it's very close to 3. So that is why they're taking the speed of light in air over here, right? Because it's very constant. Air is one of the rarest medium that we know of, right? That is why we are comparing it with air. This is called as absolute refractive index. So yes, the answer is going to be option number B. It's going to be 1.24 into 10 to the power of 8 meter per second. That's all. All right. All right, we will move on to the 7th question right now. Let's take a look at this one. It's super duper easy, because this question is very peculiar. Let me tell you why. Because there are two ways to do this question. Either you can do hard work or you can do smart work. Now, I always prefer doing smart work, because when it comes to me, I love math so much that I try to avoid as much as I can. All right. So I try to do or reduce as much calculation as possible, physically possible. So here's that question. A concave mirror focal length 20 centimeter forms an image having twice the size of the object. For the virtual position of the image, what should be the object position? Now let me just write on the given data. I want all of you guys to think carefully and then put it out in the chat box. Now the focal length of this concave mirror is given as minus 20 centimeter. The magnification is given as 2. It's twice the size of the object, but it is plus 2. Why? Because the virtual image. Now think carefully and tell me guys, for which position in front of a concave mirror would you get the image to be virtual, erect and enlarged? Which object position? When it's placed between focus and the pole. In this case, where is that position? The focal length is minus 20 centimeters. So where should the object be placed? You guessed that right, people. 10 centimeter. It has to be between the focus and the pole, and hence option number C would be the right answer. Zero calculations. Done. Just you should know your ray diagrams though. If you do not know your ray diagrams, then it doesn't make sense. Then all of this doesn't make sense to you at all. But if you know your ray diagrams, it's as simple as that. Now, if I were to use a formula also, I would still end up getting the same answer. For all those who want me to show you the formula, I'll do that as well. So F is given as minus 20 centimeters here. The focal length is 20 centimeters, minus 20 centimeters. M is plus 2. Now people, we know that M is equal to minus V by U. So M is 2, which is equal to minus V by U. So U is equal to, or you can say that V is equal to minus 2U. V is equal to minus 2U. You're taking U to the other side, right? Now, we know that, we also know the mirror formula, 1 by V plus 1 by U is equal to 1 by F. So V is 1 by minus 2 plus 1 by 2 is equal to 1 by minus 20. So multiply into 2 into 2. So that's minus 1 plus 2 whole divided by 2U, which is equal to 1 by minus 20. So this can be further simplified as 1 by 2U, which is equal to 1 by minus 20. Take it, cross multiply once again. So that's minus 20, which is equal to 2U. So U is equal to minus 20 divided by 2, which is equal to minus 10 centimeters. That's all. So the answer is going to be U is equal to minus 10 centimeters. In this case, 10 centimeters. That's it, people. Moving on to the next question. Before we go to the level 3 question, guys, like I told you, Vedantu's EdTech is back. Let me tell you why this edtech is so very important. Very quickly, guys, let me just show you this. See, people, at this point of time, right? At this point of time, if I were to go to any of the videos right here, any of the videos that of my previous sessions here. So let me just pause this video right here. One sec. So if I go to the video section, I'll probably be yeah. This is one of the videos of ICSE that came out. Doesn't matter. All right. Now, if you go to the description part, guys, you can see the Term 1 crash course for CBSE. Now just click on this link. This will take you to Vedantu's Pro subscription. Look at this one, guys. You will be getting the entire Term 1 preparations, the school preparations, the revision and micro courses, all for 750 rupees. Right now, the course is 750 rupees. This is, see, this same course before was a lot more. It was around, if you think about this one alone, this is around 1,300 rupees. From tomorrow till this next week, till next Sunday, that is, you will be getting this course for just 750 rupees after 50% discount. So if you use my coupon code AME Pro, you'll be getting flat 50% discount on the courses. So from 1,300 rupees, you'll be getting down the price to just 750 rupees. Now 1,500 rupees is the course price for Classic. But now that is also going to be 750 rupees. And see, it's the same price. I would say go with Classic because you're also getting the Vedantu's Doubt app where you can get your doubts solved throughout until your exams are done. Until your Term 1 exams are done, this course will be going on. It is not just for 1 month, it will be for the entire Term 1 preparation. Until your Term 1 is done for just 750 rupees, all the 6 subjects, including Doubts app, and all the features that you love about Vedantu, where you can see all of the replays of every single session. You'll be getting quizzes in every single session. Every single session will have quizzes. You'll have leaderboards where you'll be appreciated. You'll have stars. Again, to show you that appreciation. Because guys, in Mentimeter, only the first 10 people can be seen. But here, everyone will get an opportunity. Everyone will get equal opportunities to do better. You'll also be getting a chance to talk to the teacher, which is not a feature on YouTube as of now. You can't really talk to the person. You can't really talk to the teacher. But here on the Vedantu platform, you can even get unmuted and you can even talk to the teachers as well. And here is the best part, guys. With the teacher, you'll also have someone called as a class teacher, right? So listen up carefully. In this particular session, there were about 295 doubts that were asked. And out of that 295 doubts, 294 doubts were solved inside the session itself. 294 doubts were solved inside the class itself. This is what you're getting for that 750 rupees. And you can also download the notes. So whatever the teacher has written, whatever it is, you can download all of the notes. This is basically a mock test series that we're doing right now. So all of that for just 750 rupees. You're never going to get an offer like this again. So this is your chance to grab it, guys. All the way from today till the next Sunday, for the next 7 days, this feature is going to be on. This is our gift for you guys for your Children's Day celebrations. All right. So that's it, people. Let's get back into the questions. I hope you have a clear idea of what Vedantu's EdTech Fest is right now. The most affordable price that you can ever get out there. That is what Vedantu is offering right now. 750 rupees. 750 rupees. That's all, people. All 6 subjects, everything that you need for just a nominal price. All right. So let's get into the level 3 questions, guys. Level 3 questions are going to be a little bit more difficult, as the name suggests. It is obviously going to have some more complicated questions. So here's the question. Figure shows a ray of light as it travels from medium A to medium B. Refractive index of the medium B relative to medium A is what? Options are root 3 by 2, root 3 by root 2, or root 2 by root 3, 1 by root 2, or root 2. What do you guys think? This is an amazing question. Really an amazing question. Figure shows a ray of light as it travels from medium A to medium B. The refractive index of the medium relative to medium A is what? Now here's the thing, guys. First of all, look at this. The ray of light is entering from medium A to medium B. What is the angle of incidence here? Angle of incidence is 60 degrees. Angle of refraction is 45 degrees, right? Now, from your, okay, unfortunately I don't have any, okay, yeah, this is that. So yeah, I'm going to do it over here, guys. See, okay, angle of incidence is 60 degrees. Angle of refraction is 45 degrees, if I'm not wrong. 45 degrees is the angle of refraction. Now we know that the refractive index of medium B with respect to medium A will be sine I by sine R. This is the formula from Snell's law. We know that refractive index of medium B with respect to medium A would be sine I by sine R. Sine I is how much? Sine 60. Sine R is sine 45. Now, from the table, you guys know that sine 60 is equal to root 3 by 2. Sine 45 on the other hand is 1 by root 2. So substitute the values over here. So it's root 3 by 2 whole divided by 1 by root 2. Now this can be written as root 3 by 2 into root 2 by 1. Simple, because I'm just taking that to the numerator. I'm just reciprocating it. Now people, what I'm going to do is I'm going to multiply and divide it with root 2 just to remove this root sign. All right. So what will I get? I'm just going to do it over here, guys. I'm going to do the rest of it over here. So please pay attention. So what I have is root 3 by 2 into 2 divided by root 2. Root 2 into root 2. Root 2 into root 2 will become 2. Root 2 into root 2 will become 2. Root gets cancelled, so it will become 2. So you have 2 divided by root 2 divided by 2. 2 gets cancelled. So what are you left with? Root 3 by root 2. That's all. So the refractive index, the relative refractive index of medium B with respect to medium A will be root 3 by 2. That's how you get the answer. All right. I know that it might be a little confusing because you've not done this much in physics. There are not many questions do you come across, regarding the same. But it's important that you know this. What if you're asked a question like this? It's better to know this than to skip through this and regret it later. Right. So I would say that please do remember this, guys. Please do try out these kind of questions. It is going to be super duper important. So root 3 by root 2 would be the answer for this question. That's it. All right. Okay. 9th question, guys. Here's the 9th question. Match column number 1 with column number 2. So here are the questions. Column 1 and column 2. Ray through the center of curvature. Ray through the focus. Ray from infinite distance. Refracted ray to infinity. Sorry, refracted ray to infinity. Reflected parallel to principal axis. Converges at focus. Emerges through focus or retracing in mirror. All right. Let's start with the first one. If a ray of light is passing through, if it's a mirror, now here we're talking about mirrors, all right? If a ray of light is passing through the center of curvature, what will happen to that ray of light? If it's passing through the center of curvature, it is going to get reflected back in the same exact path. So this would be with retracing in mirror, right? It'll basically retrace it back after reflection. It'll retrace back the same path. If a ray of light is passing through the focus, then what is going to happen? If a ray of light is passing through focus after reflection, it will become parallel to the principal axis. Again, yet another standard incident ray. Third one, ray from infinite distance. If a ray of light is coming from infinity, then all the rays of light are going to be parallel to each other. We are taking only those rays of light which are parallel to each other. So after refraction, they will basically converge at the focus. Again, one more standard incident ray. The last one has to be the option number C itself, that is reflected ray. If a ray of light is coming from infinity, refracted to infinity, then that will emerge through the focus. That is after refraction, if a ray of light is coming from infinity, then after refraction, it is going to pass through the focus. That's all. So that will be the answer. Simple question, guys. Very straightforward, very easy. So the answer to this question would be option number A. That's all. First with D, yes. Second with A, yes. Third with B, yes. And fourth with C. Alright people, the last question for the day. I have a homework question for you guys as well, but this is the last question for today. So here is the question, guys. Assertion is an object is placed at a distance of x from a convex mirror, focal length f, and its image will be formed at infinity. Reason is the distance of image in convex mirror can never be infinity. Options are both assertion and reason are true. Reason is the correct explanation for assertion. Assertion and reason are true, but reason is not the correct explanation for assertion. Assertion is true, but but reason is false, or assertion is false, but reason is true. Think, guys. If an object is placed at a distance of x in front of a convex mirror of focal length f, the image is formed at infinity. Can this statement be true? Think. 5, 4, 3, 2, 1. No, it cannot. Because it's a convex mirror. The image is always going to be formed between the focus and pole. Always going to be formed between the focus and pole. So it can never be at infinity. But reason is true. Because the distance of image in a convex mirror can never be at infinity, because it's always formed between the pole and focus. So the answer for this question, guys, would be option number D. Assertion is false, but reason is true. So that is the end of the last question, guys. But yes, I also have a homework question for you guys. This is your homework question. Try your best to put down the answers in the chat box, in the comment section. Let me know if you guys have gotten the right answer. And more importantly, tell me out of 10 questions, how many questions did you get the right answer for? Let me see how many of you guys are genius and geniuses. Let's go. All right. So here's the question, guys. The power of a convex lens is positive and that of a concave lens is negative. Reason is convex lens forms real image and concave lens forms virtual image. Options are assertion and reason are true. Reason is the correct explanation for assertion. Assertion and reason are true. Reason is not the correct explanation for assertion. Assertion is true, but reason is false. Or assertion is false, but reason is true. Let's go. All right. So let me know the answer for this question in the chat box, guys, in the comment section as well. I will see you guys in the next one. Until the next time we meet, this is Anoop signing off for the day. Ciao, adios, konnichiwa. See you soon. Let me know the answer in the comment section. Subscribe to the channel. Hit that like button. See you soon in the next one. Take care. Until then, this is Anoop signing off for the day, and happy Children's Day. May you guys be blessed. Bye-bye. See you soon.